We have the lecture 5, we just start and give you the examples. The theory we have just discussed in lecture 4, we apply that one and we've tried to solve it. Where I've been taking here the 6 examples from different point of view. So the different types I want to discuss. Here we have the differential equation, second order differential equation, find the solution. So as I mentioned here, we take the method is that we find to take here y is equal to e to power mx, and we say this is not equal to 0. When I substitute this one, I get characteristic equation directly. I can write, as I explained you before, the characteristic equation for this one is m square plus m minus 6 equal to 0. I factorize this one. I have two factors. For 6 we have minus 2 and plus 3. We are having m plus 3 into m minus 2. So when is equal to 0. So you remember the formula here, that m plus a into m plus b is equal to m square a plus b m plus a into b. So when multiply these two, we get here this value, and we add, we get this value. So we're having here minus 2, minus 3, minus 6, and we add them, we get here 2. So we get here roots m plus 3 is equal to 0 or m minus 2 equal to 0. I get here the value of m equal to minus 3, and we get here m equal to 2. We have the real roots. This is my m1 is equal to minus 3 and m2 is equal to 2. I get two solutions. Y1 is equal to m1x, and m1x is here equal to e to power minus 3x. And my y2 is equal to e to power m2x, and m2 is 2, so get e to power 2x. Now they are linearly independent. We can write the general solution. Y equal to c1 y1 plus c2 y2. I get here c1 e to power m1x, and that is minus 3x plus c2 e to power m2x, and that's e to power 2x. So this is the solution of my problem. So this is my example 1. I take the second example. My second example is, these are the roots for real. Here they were real, and m1 was not equal to m2. Now we take the second example, example 2. I want to solve the differential equation. And my differential equation is y double dash plus 2y dash plus y is equal to 0. Here is y dash. Again, we take here the solution of this one. For solving it, we always substitute y is equal to e to power mx, and we get the characteristic equation. Characteristic equation for this one. Equation that's equal to m square plus 2m plus 1 equal to 0. Factorize this one. We get here two factors. 1, when we multiply, we get 1. When we add, get here 2. So get here m plus 1 equal to 0. So get that two roots, m plus 1 equal to 0. Or we having here m plus 1 equal to 0. So get two values, m equal to minus 1 and m equal to minus 1. So we having the roots m1 is equal to minus 1, m2 is equal to minus 1. So get here one solution, y equal 1 is equal to e to power minus x. And for the second solution, we use here y2 is equal to y1 integral e to power minus integral p of x dx over y1 square into dx. Now here, when we have these two roots are equal, when we solve this one, the y2 will be always equal to x y1. So my y2 is equal to x for repeating roots, and my y1 is e to power minus x. So this one give me the general solution. I get here y is equal to c1 y1 e to power minus x plus c2 y2 is x e to power minus x. Please note this one, and this is very important. Always will help you that when the roots are repeated, we multiply by x. How we solve this one, and we get here exactly the result. As I said, we take e to power minus x, solve it. We get here x e to power always. For example, I have here the roots. M is equal to 2. M is equal to 2. I want to write the general solution. What is the general solution? The solution is y is equal to c1 e to power 2x plus c2x e to power 2x. So for example, I having m equal to 3 m equal to 3, m equal to 3. There are three roots. This m1, this m2, this m3, they are equal. So y equal to c1 e to power m1x plus c2 x e to power m1x plus c3 again multiplied by x square e to power m1x. So here when we having three roots, we multiply by x and then we multiply by x again. Similarly, we having the four roots are equal or five roots, so we can do the same strategy to write our general solution. When the roots are repeating, we can apply it and we can solve it with the help of this one. We take the third example, example 3. We want to solve the differential equation. The equation is here given to me is y double dash plus 2y dash plus 5y equal to 0. So solution of this one, we substitute here y equal to e to power mx and we get here characteristic equation of this one. We get here m square plus 2m plus 5 equal to 0. So I can't make the factors. So I go for the method that's my formula minus b plus minus root of b square minus 4ac over 2a. So this will be is minus 2. So get here 2 is get minus 2 plus minus root of b square. Here is 2. We get here 4. 4ac 4 multiplied by 5 is 10 and 20 and this is minus 20 over 2a. A is 1. We get here 2. So when solve it, to get here minus 2 plus minus root of minus 16 over 2 and that give me here minus 2 plus minus 4i. I explained it before and we get here minus 2 over 2 plus minus 4i over 2 and that give me minus 1 plus minus 2i. So give me here the value of alpha is equal to minus 1 and beta is equal to 2. So I have the solution when we want to write for alpha plus minus iota beta. What's my general solution? Y equal to e to power alpha x. Then you can c1 cosine beta x plus c2 sine beta x. That's my method. I show you that one and we apply this one here and we having alpha and beta, substitute here, we get the general solution y equal to e to power alpha. Alpha is minus 1, so e to power minus x. Then here c1 beta is 2 cosine 2x plus c2 sine 2x. So that's the case when you having the complex roots, we have the solution. I use here the quadratic formula to find the roots and find the value of alpha and beta, and then we use the our formula for writing the solution. When we have the complex roots, we put the value of alpha and beta in our general solution. Alpha is 1, alpha is minus 1, beta is 2. We get this as our general solution. So we take the next example, the example 4, and we try to solve that one. In example 4, we are having here third order differential equation. The last two examples, we are taking the second order differential equation. We are having here y triple dash and here minus y double dash. Then we are having minus 5y dash and minus 3y equal to 0. This is my equation. Want to solve it, we write this, we use the substitution y equal to e to power mx and that give me the characteristic equation. My characteristic equation or auxiliary equation some of the book are using. We get here m cube minus m square minus 5m minus 3 is equal to 0. And there are techniques for solving the equations which are the third order differential equation. One way is we get the trial solution, then we divide it and lower the order of differential equation and then we solve it. We take the trial solution, we take m equal to 1. When we take m equal to 1, we get here 1, minus 5, minus 3. It's not equal to 0. So m equal to 1 is not the solution. Then we take m equal to minus 1. When we take m equal to minus 1, we get here minus 1, we get here 1, minus 1, we get here plus 5, we get here minus 3, we get here minus 5 plus 5 is equal to 0. This means m equal to minus 1 is a root. So when we get this as root, we then divide our equation with the help of m minus 1, then m plus 1. We get here m square minus m square, m cube, m square minus 5m minus 3. We divide by m plus 1 because the root of the equation here we will make it 0. So we get m square, we get here m cube plus m square, minus is cancelled. We get minus 2m square minus 5m minus 3, then got gone by minus 2m So get here minus 2m square minus 2m, this become plus, this become plus, we cancelled, and we get here minus 3m, minus 3 is gone by minus 3, so get minus 3m minus 3 and change the sign, we get here 0. So we can write this equation, this one we can write as m plus 1 into m square minus 2m minus 3 equal to 0. Now we look at this factor, which is quadratic one. Can we make the two roots? Yes, we can make. So we get here m plus 1 into, and we make two parts of 3, which make multiply, we get minus 3, and we add minus 2. This is minus 3 and plus 1. So we get here m square, m plus 1 into m minus 3 equal to 0. Here we can see when we multiply, we get minus 3, when we add, get minus 2. So we get the roots are of these equations are our m1 is equal to minus 1, our m2 is equal to minus 1, our m1 is equal to 3. So here we can find these roots are repeating. These roots are repeating, m1, m2 are repeating. So we write our general solution. Our general solution is y equal to c1 e to power minus x. Then we are having c2, because root is repeating, so we multiply here by x, and we get e to power minus x. They become distinguished from that one. Then c3 e to power 3x. So that's my general solution. In case we are having here two roots for repeating, and then one is, and they are real roots, but here we have to find the factorization of that one. For factorization we use the trial. First we have taken this m equal to 1, and this was not equal to 0, and take n equal to minus 1. This make it to 0, so we say m equal to 1 is a root, and then we divide it, get the quadratic equation, then we factorize that one, and we get the solution of this.